So, when's supposed to stop it?
Then your phone. That picture I sent you. I sent you a picture. I just need it so I can write in the. Yeah, I need it for the negative angles.
It's probably locked, man. It's probably locked. The screen is
turn
locked.
it the other way. Rotate. Why is that?
The screen is
Sign
locked.
it in the internet because you're not there.
Okay,
Okay,
right,
that's
you can
fine,
see
that's
it.
fine. I just need.
Yeah, so, you're recording, yeah?
Yeah.
Was that from a previous lecture?
Hmm?
Was that from a previous lecture? Or you just
Yeah, no, in Bria when I used to teach, my board was long. So I used to keep these rules on one half of the board.
Yeah,
So when I'm teaching, I just go back to that one.
that's a cool idea. This is not in the textbook, huh?
No, I don't think
Yeah.
you. But it's based on the same principle, like how, like what Trevor would have
This,
said. You know, like you said, the costs of negative of the angle,
Yeah.
and then negative angle you normally would add 360,
Yeah.
right? So it will become, if you look at it, cos of a negative angle, right? What you would have done is you would have said cos to negative angle plus 360. If I just rearrange this, it's the same as saying cos of 360 minus the angle. Yes? Same thing.
Yeah.
And 360 minus is a positive value for
alright,
cos.
okay, get it.
That's how cos of a negative angle is cos theta. But remember with sine, it's the same thing. If you said sine of a negative angle, and I told you that you would add 360, so you would have said sine of 360 minus the angle
Yeah.
to come straight like this. But 360 minus is what constant? 4.
What constant?
Sine is negative
Negative.
under 4.
Okay.
So that's why this, and this would be negative. Second cos would be positive.
Okay.
Okay?
So you can work it out.
You can. That's basically what the derivation of how they got to that. But why you would use this is in terms of simplifying questions. If they tell you sine of 180 plus and then angle, then you know you'll have to say negative sine. And then if they give you a negative angle, like that, sometimes you will get stuck. But it's just simply looking back at this
Quadrants,
diagram
yeah.
and you're getting that, right? So this is about 90% of the rules I need you to know. And then the one more set of rules is
Cofunctions.
coefficients. Yeah, cofunctions.
That's not that bad. Okay.
Guys, you're almost not taking it down?
Even that too, you don't have to learn off by heart.
No.
That you can.
If you
Figure
know
out,
this,
yeah.
you can apply it there. So,
I'm just thinking the less you gotta remember, if you understand
Okay.
everything else, it's just as I said, it's triangles, those two on the top there, and half angles. That's it.
But the nice thing about this textbook is they got a lot of examples here.
Mm.
Which you can use.
Yeah, I mean the pi thing.
Yeah.
You know your between
Pi and degrees.
yeah, so you know you're solving for between a set like 0 between 0 and 360, 0 and, yeah, and then you say pi over 2, but you can do that in the examples, I think, huh? to cover
You
that.
know when they're saying pi, what they basically referring to that,
Yeah.
Right.
right? And pi rad is equal to how many degrees?
Oh, pi over that.
180.
180.
180.
Same.
No.
If they tell you pi over 2, it's basically them
90.
saying 180 over 2, which is
perfect.
90.
Right. That's perfect. Please explain that to us.
I just explained it to you.
How to convert it.
Just
No,
divide
put
it.
it
So,
back.
if the, you know that pi is equal to 180 degrees, right? Right? And if they give you limits of pi over 2, okay, negative pi over 2, your angle, and then pi over 2, right? And they tell you, obviously, when you're working off your angle, it must lie between that, okay? If you are to convert this to degrees, pi is 180. So this is the same as saying 180 over 2. So your answer basically needs to lie between negative 90
And positive 90, right?
and positive 90.
Okay.
So whatever your degrees work out to, it just needs to lie there.
That's perfect, right? I know where 90 is. Where is minus 90 on the
Where?
yeah on the diagram?
Oh, the way when you turn
Yeah,
the
when you
house,
determine
do
it,
So if you're moving in this direction,
yeah,
in a anti-clockwise direction, you count your angles as positive.
right.
If you're moving in a clockwise direction, you would say negative. And how that comes about is, you see when we...
So wait, so minus 90 will be in the bottom where 270 is.
Yeah, but what I told you with the negative angle, what
You switch it 360.
you add 360.
Yeah.
360 plus 90, well, 360 minus 90 is what?
Yeah.
270, which takes you back there.
Oh.
Okay? That's basically what they're referring to. Understand?
Yeah.
Okay? Compound angles you're okay with.
What you mean? Okay, in which way? We know the formulas now.
Yeah. But in terms of like an application of it, you'll understand.
No, we haven't
We haven't
done.
done.
In all these things here, we've done. We've done. I'm being honest with you, right? So we've done cast diagrams. He's done a few special triangles. We've done that, right? From compound angles all the way to double angles, we haven't done much examples.
Yeah, I think we just
He did
did
one
another two
example from the
examples,
textbook
and
for that, one example for this, and that was it. Nothing else. I'm telling you where we are at the moment.
Like
Yeah.
that.
No, so I'm thinking, so I know Monday how much more of
Yeah.
it
Yeah.
to do. He did that example with the calculate sin 15 without the use of calculator.
Yes.
And you'll understand how it is.
Yes, that's just the triangles. Easy.
Sure. You break up the 15
Break up, yeah, we
into
did
two
that.
of your special angles.
Yeah.
Right? Something like that. So if I had to tell you to cost of 75, you'll would not do it.
Yeah, go either. You do it multiple ways, is it?
Okay, if I had to tell you solve for cost of 75 using compound angles, you will not do it. Yeah, and then from there you'll use the compound angle formula. Can I take this up?
Yeah,
Yes.
but yeah, the two examples.
No, I'm just doing 1 and 2 so I can see, and then Monday I'll do a
Yeah.
Yeah.
few. Only nice thing about maths is I can think of examples while I'm standing here. With
While you're
science,
sitting, you
with-
can't, sir.
no. with science you can't do that because you saw the way they ask questions in science.
Yeah.
They give you a whole story about it. With maths I can just tell you.
No, but we understand, Jeff, it's not easy for you. I think you have to go back and learn the syllabus in a couple of 2 days or so.
But it comes back,
So-
it's just that the
So
typing
we
techniques.
appreciate it, yeah.
Thanks. Okay, so solving for cos of 75 degrees, right? Without the use of a calculator, and you will have to solve for it. Okay, so also, which other way would you have used to solve this if you wasn't using compound angles?
Calculator?
That
No,
no,
without
no.
the use of a calculator.
Triangles.
Triangles. Yeah, you can use
But
triangles, compound angles, you can use. You can use.
Okay.
But how would
When
you-
you say triangles, how are you going to get to that point of actually using them?
So you have to break the angle up into 45 and
Okay,
30.
so you'd say cos of 45 plus 30. And then what should you do after? You went to your triangle and put it.
No, then you say what cost of 45 plus cost of 30, isn't it?
You can use.
So you're over there went to your triangles
Yeah.
at this point. No, you can't do that. right? At this point here,
That is
basically what you have is cos of A plus B, two different values. Now, cos of A plus B, what formula is trying to look like?
compound angles.
Compound angles, right? So what the formula would have been, it would have been cos of A plus B is equal to cos A cos B minus sin A sin B, yes?
Yeah.
Okay, so what you would have done here now remember this is the same as that, right? So this would have been cos of 45 times cos of 30 minus sin of 45 times sin of 30. Right? Now you can go to your special angles, your triangles. So what's cos 45? Without calculator.
1 over square root 2.
Without calculator.
1 over square root 2.
1 over?
1 over square.
He's bullshitting.
I'm serious. Why not?
It's square root 2 1
It's funny, yeah.
Square root 2 1. Okay, cos of 30?
Square root 3 over 2.
Yeah.
Minus? Yeah.
45 sin, so 1 over square root 2. So
1 over?
square root 2.
Square root 2.
Yeah. Yeah.
Yes.
Right? Sin of 30? I want you to look at the triangles so you'll know. What is it?
1 over 2.
1 over 2. Right? Now it says solve without the use of a calculator. So how you would have done this? This multiplied by this is what?
Square
The
root
numerator is 1 times root 3 is
root 3.
root 3. And 2 times root 2?
2 root.
It's 2 root 2. Right? Minus 1 and 1 is 1. And then that's 2 root 2. So now you're just left with root 3 minus 1 all over 2 root 2. And that would have been your answer. Okay? So that's how you would apply compound angles to a question. Okay? So you look at it, you try to play around with it to try and get it to two special angles that you can use to calculate it. Okay? And then from there, so you'll either add or subtract or do something, get it there. And once you hit this point here, it's just really. How they catch you out, I'm sure I told you how they catch out the calculator is. When a calculator gives you the final answer, it rationalizes its denominator.
So let's see.
So that's how they catch you. Checking it. What you have got root 6 minus root 2 over 4.
It's like a mathematician, you know.
Yeah, I enjoy maths, but I don't think we know that.
That's 1 over.
So you can simplify this further by multiplying it by.
If they asked you to rationalize the denominator, you know you would have done it. But when you put in the calculator for 1 over root 2, it gave you root 2 over 2. You want to know why it gave you root 2 over 2. Okay? So, in a normal circumstance, you can't have a square root in the bottom. Okay? You need to rationalize your denominator. So, when you put 1 over root 2 into your calculator, this is what the calculator did. It rationalized it by multiplying the numerator and the denominator by whatever the square root is. So this was square root 2 and this was square root 2. This now multiplied into root 2, and then what's root 2 times root 2?
2.
2. Do you understand why it's 2? Why it's just 2? Remember with the square root, right? A square root is basically 2 to the power half. Y'all know that, right? Everybody?
Yes.
Okay. So when you're saying this times that, you're basically saying 2. So with the same basis, when you multiply same basis, you add the indices, right? So when you add half plus half will give you 2 to the power 1. 2 to the power 1 is 2. So that's how they got that. When they rationalize this here, if I had to tell you further, rationalize your denominator. How would you have rationalized it? You would have said times root 2 times root 2.
Or not 2 times root 2.
No, not 2 root 2, right? So when you multiply this out, you would have ended up with, remember this is one
2 times
term, right?
Yeah.
When this root 2 multiplied by here, you were left with 2.
2.
And 2 times 2 would have given you 4. When you multiply this out, what will happen to you? Root 3 times root 2. Because they both under the same surd, it will just become 3 times 2, which will make it 6, and then times that would be minus 2. And that's how, if you put cos 75 in your calculator, you would have came to this.
Now hold on, right. If you're working out the special angles on the calculator, all you have to do is multiply it.
If you work in your
yeah, and you work
calculator,
out what's
just take this and put it here and put a 1 on top.
That's what I'm saying. You can
Yeah,
that's really
because
you
that's
have to
how
remember
they-
the angles and the triangles too.
Yeah,
It's one less thing to remember. Right?
So which is the correct answer?
both are. This is the answer you get without the use of a calculator, right? If they tell you rationalize your denominator, rationalize your answer, you would have done that. So both are correct. If you put both these in the calculator, if you put this in the calculator, it comes back to this. And if you put cos 75, it comes to this. It's all the same thing. You just rationalize one, and this here basically shows you use your calculator. This one shows you didn't. You're okay with that, right? Three is just like sort of a recap. I'm trying to see where we are.
Yeah. Okay. Cool.
Okay.
You look at our maths and engineering marks back. You gave the marks here.
Yeah. The maths. They
Almost
marked
done.
the maths. They gave it to us. Trevor.
Mark maths.
Yeah. Hopefully we'll get it back before
Okay,
we
tell
start
me
in
it's-
5.
Hey, David.
Yeah.
No, I'm serious.
I'm gonna give it to you by
Let's
Tuesday.
leave application after we have
Yeah,
to
yeah.
live.
Tuesday, by Tuesday.
He's we can help you more if you want.
Yeah, we can do it as a group group exercise.
And take it again.
Yeah.
Okay, today we're gonna do co-ratios, or sometimes it's called co-functions, and I'm gonna do the derivation with you all, right? Of how they got to it. Little bit tricky, but not impossible. Okay, so I'm on page 117. So if you're looking at functions of 90 plus a,
117.
117.
It takes me to your face. It takes me to your face.
Okay, so we're gonna follow what they're saying, and I'm basically gonna show you over here, right? The diagram also, there's one or two things that's a bit off there, okay?
Which one? The one in the textbook?
Yeah, I'll tell you what is off there, right?
It's where they measure the angle from.
No. Okay, I'll show you, okay?
What is that? It's supposed to be a semicircular.
Why did you do that?
It looks like, I don't know what it looks like. So you're doing the proof, huh?
The
Okay,
proof of it, right?
Okay.
So guys, this will be the proof for functions of 90 plus a. That's it, right? So they tell you let OX rotate to a position OP to create an angle of XOP, right? So let OX rotate to OP to create this angle of A. Understand that? Rotate OX further for a further 90 degrees up until OP. So basically this OP line, it rotates and for 90 degrees So that's 90 degrees until he creates this line here, which is, I'm going to call it P prime.
So it's a semicircle, I think.
Okay.
Yeah. Okay.
That was 90.
I'll point it out that it wasn't. Let it a bit more. P prime there. This will be M prime there. So this angle here of P prime, O, and P is 90. You all see that, right?
Yeah.
This angle here is 90. Okay, cool. So they tell you that triangle OPM is congruent to triangle OP prime and M prime. Do you understand what congruency is?
No.
Congruency is
Negative.
basically, no. Congruency is when a shape has the same, when two objects has the same size and the same shape. Okay? So congruency is same size, same shape. Okay? So basically, if you look at this triangle like this, and if I put it directly over this, it will fit perfectly on top of it. That's what I do. Okay, so if I flip it, it's like that. Okay. So, what does this mean? Right?
Yes.
This means that OM, line OM is equal to which line?
PM.
Which one?
PM.
Well, P prime,
Yeah.
M prime. Agreed? Everybody can see that? This line here is equal to that line there.
Oh, okay,
Can you
yeah.
As
see
it's
it?
clever said, you're
I
gonna flip in the
tried
triangle.
to draw
around.
it,
Yeah.
Okay, see?
Yeah.
like where you can see it there.
How you
The
get
shortest
over
line.
now?
Yeah.
The short.
How does that?
It's not flipping, that's what I'm telling you.
It's like,
it's not flipping.
OM is the short side on that side. As you move it this side here, the PM will be the same, the shorter side. I'm not to explain it. Yeah, it's,
Can you all see that this line and that line are equal?
Yeah.
And it's also congruent. Basically, actually congruency is the same size and the same shape. If I take this triangle and put it over that triangle, it will fit perfectly over that triangle, right? So, this is the side that will be equal. OM and that side will be equal, right? The next side that will be equal would be this one will be M, PM. So PM and well, we'll start from OM. Okay, right? So you get it there? So it's this line here and that line coming down.
okay, right.
Okay? And the last line that would be equal would be OP and OP prime. Okay? So all we basically did was our triangles, this line started from OX, right? We rotated the line up until point P and it created this angle E. Okay? From there we rotated it to P prime at 90 degrees. So now this entire portion here is 90 plus A. Do we agree?
Yeah.
Okay? Because this angle of A plus that 90 degrees would give you whatever that angle is. Okay? So, if I had to say sine of 90 degrees plus A, what would that be equal to in terms of trig ratio? So opposite over hypotenuse. Okay? This is 90 plus A. You remember earlier on when I told you that if I had sine of 135 and if you had to break it up, right? You could have broken it up into 180 minus. Agree?
Yeah.
Or you could have said 90 plus 45. Okay? So, but even if you said 180 minus, right, you could have said 180 minus 45. 180 minus is positive in the second quadrant. So, this answer comes up to sine 45. So, what does that tell you? That two things are equal. Yes?
Yeah.
So, Here, the value that you will obtain for sine of this angle would be equal to sine of 90 plus 8. You're okay with that?
Is that the last part again?
Sine of this angle here would be equal to sine of 90 plus 8, that outside portion. So this part here, 8 prime, would be equal to 90 plus 8. Can I understand that, right? Guys, are you with me? I'm sure you're with me.
No.
It will give you the same answer.
It will give you the same answer, right?
Lower angle.
Because you see over here, basically when we broke down sine 135. Sine 135 we could have said is sine of 90 plus 45, right? 90 plus the angle. Okay? So 90 plus the angle would be equal to the same as using sine of 45, right? And 90 plus this angle here, it's the same as you working on this part here, the inverted part of it. Y'all can see that, right? So the value you would have obtained here is the same as the value there. So if I had to ask you now, using this point here, for sine of this, what's the sine equal to?
PM over P.
Well, P prime M.
P prime, yeah.
P prime M prime all over.
P prime O.
Yes? Good.
No, wait. No, it's wrong, right?
What?
Sine. Is that sine?
Sine, opposite, yeah.
So if the angle was here,
Yeah.
opposite?
Yeah.
Oh, hypotenuse.
Hypotenuse, yeah. It's
Sorry.
P prime
This would have been
over
OP.
Yeah.
Right? That's fine. Guys, does everybody understand what I did here?
Don't let that happen again, huh? Please.
Right?
No, we can't be correcting you.
Okay. You understand this, right? Okay. But didn't we say that these lines are also equal to this point?
Right, yeah.
Okay. So if I change this now to this point here would be OM and OP prime would be OP. Yes? Whereabouts are these lines? OM and OP. For cos of A.
Cos of A.
Cos of A, OM, OP. So this here will also equal to cos
Of A.
of A.
And we proved it.
Do you understand? And this is the proof because we are saying that sine of 90 plus A equaling cos of A. Who's completely lost?
I'm lost there when you come in with cosplay.
Here. Okay. So, okay, you understand how I got this part, right? When I said that we take this point here because whatever this is equal to that angle as well, right? Not the angles are not equal, but the value sine of this would be equal to sine of that, right? So sine opposite over hypotenuse gave us this. We said P prime M prime is equal to OM. So I just swapped that for OM. And then I swapped OP prime for OP. Right? So it's OM over OP. Now let's look at where OM and OP is. Right? This is OP, OM. This is OP. Relative to the angle, this is your adjacent. This is your hypotenuse. Adjacent over hypotenuse is cos of A. So OM over OP is the same thing as saying cos of A. So what we proved was that sine of 90 plus an angle is equal to cos of that angle. So in this point here, you could have worked it out two ways. You could have said sine of 135 would have been sine of 180 minus 45, and then you would have said this is equal to sine of 45 degrees, right? Or you could have said sine 90 plus 45, and we said 90 plus 45, sine of 90 plus an angle is equal to cos of that angle, right? So you say cos of 45 degrees. Understand?
So, So you make that A maybe 6 degrees.
Make it a different number.
Yeah, make it a different number. Because that's where,
But it can't be 6. Not.
Just for the
just
sake
for
of it, right?
the illustration.
Right? I actually wanted to do a different numbers because I want you to put it in your calculator to see, right? Say the sine of 155, right? How you would have broken this up? You could have said sine of 180 minus what? 25. Yes? Right? 180 minus is second quadrant. Sine is positive in your second quadrant. So this here would become sine of 25 degrees, right? That would be that's how we simplify it. And from that point, you put it in your calculator. Okay? Sine of 155, again, we could have said sine of 90 plus 125 to give you 155 would have been 65. Okay? But we said sine of 90 plus an angle is equal to cos of that angle. So this here would be equal to cos 65 degrees. Okay? Put sine 25 in your calculator and tell me what you get.
0.42.
0.42 and then put cos 65.
Same.
Same. Now you may be wondering what is the need to do this, because we can always use 180 minus, right? In certain simplifying questions, you could need to get everything. Okay, in simplifying questions, you're gonna try and get everything to the same. Like all are gonna end up cos, so all are gonna end up sine, all are gonna end up tan, right? But in an instance like this, if you need to convert the sine 155 into cos, how are you going to do it with only 180 minus? You're not going to be able to swap it, you can't do anything about it. That's going to end up becoming a factor there that you can't get rid of, where you're not going to be able to simplify it. But how could we have simplified it? We could have used co-ratios and converted it into cos 65. And then from there we can cancel off and simplify that sort of thing. Okay, so do you understand the
Just one thing, man. See, I know you're using prime, P prime, M prime, and all
Yeah.
those things here. What if I just use different letters?
that's fine,
Yeah.
but see, whatever you call this triangle, call it the same thing here, but the prime is basically like a reflection or a
Mirror image, like
mirror
a.
image of the other point. Okay?
Okay.
So main thing you need to know for your derivation, right? Because up until this point here, you can use everything up until this point here to solve for any of the co-ratios that they ask you if it's 90 plus. Okay? So if they are to ask you for tan of 90 plus A, you come here, tan would be what? Opposite over adjacent. So it will be P prime M prime all over O M prime. You would use these here to swap it. You will come to this triangle. Find those points and see relative to the angle whether it's cos, sine, cot, whatever. And that's how you would get it. Do you understand?
Yeah. How many do we have like that?
And how many marks?
12.
So we have two. But you know one method, it's just the 12. But that's not given to us, huh? Those 12.
Co-ratios.
Yeah. You'll have to just know it off by heart.
But if you learn the derivation and quickly in your paper you just draw this triangle. Right? No, because it's not, it's two triangles,
Yeah.
right? Whatever if you need the thing, you can just do it quickly. Take you like 10 seconds to do it. Okay, guys, do you understand the derivation of this? You want me to do
That's
one?
how you
You want me
prove
to do one more like
I
this?
think do one more.
Okay.
And that's how you prove it.
Different
Hold on,
example.
let me take a photo.
No, I'm not taking it. I'm not taking it. Okay, before I continue, does everybody understand what I did here?
Yeah. I got it.
You understand? You understand what I did here? I basically showed which lines are equal to each other. Because these triangles are congruent, or you need to say that, you need to say that triangle OPM congruent is 3 lines. Okay? No, that's similarity. Congruent is 3 lines coming down to triangle OP prime M. Line
Yeah.
of the angle.
PM.
Okay. So you basically stated these triangles are congruent. So for you to say this point, you need to say that the triangles are congruent. You can't just guess and say that these lines are equal to each other. Once you get this part, you can do it. So I'm going to do another one there. Marking blank. So okay. So if I had to ask you to prove cos of 90 plus A, how would you prove cos of 90 plus A? Now you would have do this, you would have said this, you would have been here now. Okay? This is where we are. So cos of 90 plus A. Cos of 90 plus A, remember I said we can look at this angle here because it will still be equal to each other. Cos of whatever this angle is will be the same there. Okay? So cos, how would you write that down? In terms of these sides.
M prime O.
No, it starts out from here. So you say O M prime.
O M prime of O P prime
You understand that? You understand?
adjacent of a hypotenuse.
Yeah.
Yeah.
Okay? So this would be O M prime all over O P prime. If this was where the angle is, this is equal to 90 plus 8, right? This would be adjacent, that would be hypotenuse. Okay? If we're looking at these sides, OM prime is equal to PM. So, PM all over. OP prime is equal to OP. There's PM, there's OP. Okay? In terms of your angle, where this angle A is, PM is where? Opposite. And OP is your hypotenuse. Opposite over hypotenuse is what? Sine. So, you could have said that this is equal to sine A. Therefore, cos of 90 plus A is equal to sine of the angle. And you prove. They'll ask you, prove cos 90 plus A is equal to sine A. Show this, and you do that. That'll be like 5 marks.
Okay.
That's all.
We're not doing figures and.
No, you're just
proof.
drawing this thing
Yeah.
here, right? You're saying the triangles are congruent, you're saying that these sides are equal. Once you say the sides are equal, you can show that part and you're done. Okay? They'll either give you between this derivation and compound angles derivation.
So compound angles you need to do it with Rowan.
Monday I'll do compound angles, Monday I'll do more examples on compound angles, double angles. That even the 1, 2, the quadrants, you know, when you're working out the amount of the angles and blah blah blah.
Sorry man, isn't there some negative figures here on these ones? They're all positive.
No, there is
You can do one with the negative.
so
Just show us how it switches to a negative. See,
I lied about something.
he lied.
I never lied, but
You've got that on camera, guys. You're right. He lied to us.
I don't lie. Remember this line here, OM,
Yeah.
right? If this is the axis,
Yeah.
will this line be a positive or
It'd be
negative?
negative.
It would be a negative value, right?
Okay.
So OM prime would be negative. Now that negative would also carry downwards, okay? So negative OM prime would be equal to negative PM. The OMs will swap, right? But the sign would still stay. Because remember, all I did was I replaced OM prime with PM. You understand that, right? So if that's in a bracket, it's still going to be negative, so you end up with negative sine A. They added the negative one.
So
And
OM
this
is
one?
negative, why is PM negative?
This one
Because
is the
see
same.
exactly.
Sine.
So like if I told you x is equal to y, right?
Yeah.
And if I wrote negative x, What if you had to write in terms of y? What would it be?
Negative.
Negative y.
Ah, okay.
So it's the same thing. I just swapped the term O and prime
But how
for
do you know when it's
That one
negative?
state.
it.
If it's on that side of the.
But see, this is positive because your y-axis is positive here.
Oh.
So the only thing that would be negative is O and prime,
Oh, okay.
right? Because it doesn't go down into the other extreme.
Because it's on the other side.
Yeah.
Yeah, because remember from here to here it's negative. In terms of a normal Cartesian plane,
Yeah.
But Rohan, there must be a simpler way to learn all these angles, man.
I'm Jaffel.
sorry, Jeff.
I'm
Yeah.
Jaffel.
Sorry. It's must be a simpler way to learn all. Huh? Why are you
Oh, you're
insulting me
insulting
again?
me. I didn't pick on you, you're insulting me.
So, what I'm saying is, this is a lot to try and figure out in the with the negatives and stuff. Is there no simpler, like, then you have to
In terms
cast
of co-functions, I never got
a way to
A simpler
remember
way to figure
remember
this out.
because there's something they said this
the only
curve,
way
right?
you can is you see if you draw this,
Yeah.
you can just work it out quickly as we
I
go.
think more examples you do, you probably
You'll get
figure
used
out.
to it.
Yeah.
And then
One
you'll
with
see
ten.
this.
Do you do one with tangent?
There's for everything. There's for
For
sine,
everything.
cos, tan, cot, sec, cosec.
Maybe just write all the stuff down there.
That's what I'm doing.
Okay,
So this is the derivation for functions of 90 plus a. Then I'm going to do the derivation for 90
Minus.
minus a. And then I'll give you all your correlations.
So this is derivation now.
The proof.
Proofs.
This is how the formula was derived.
That's that same big section towards the end of
No, that's differentiation.
the. Oh, okay.
That's calculus. Differentiation and integration. That's a whole nother
Okay.
demonic evil thing.
That's another
coming to
monster.
us.
Oh, okay.
Okay, I can take it down now. I got it. I took it.
Yeah, let me take a photo quickly.
That's a 10.
How about that?
What was 10?
20 plus 10.
20 past 10.
Yeah.
5 minutes happened so fast. In the space of you giving me the 10.
He's got it.
I'm way ahead of them, Jack. Huh? Oh, it's the other way around. Sorry.
Get it? Sure. This is just derivation. If you by heart it and you go do it, it's fine. So that's the tool.
So you basically have to bar the first part.
Just this. If you know how to draw this diagram,
That's it.
you sort it.
As
But
well as
whatever
the
they
diagram.
give you after, sort it.
So the diagram that was wrong here was it just didn't have 90 degrees to show that this diagram, yeah?
Yeah, what was wrong over there was
90. Yeah.
not the 90. See where the how angle A is formed.
Yeah.
They start from the X and they move it onto the Y. It's not supposed to move onto the Y, it was supposed to move onto the line OP.
Oh yeah. OP.
Yeah. Okay.
That's what I couldn't figure out.
Wasn't working out, sir.
Get it?
Right. Yeah, that's
That's a
right.
good problem.
Okay, so I'm on page 118, right? You'll see at the top of page 118, give you a few more on how they got to tan and how they got to sec. Okay, so you can practice that and see how it is. Okay, so two angles are complementary if their sum is a right angle. So two angles are complementary is if you add both those angles together and be equal to 90 degrees. Okay, so let triangle ABC be a right angle triangle. Angle A would obviously be equal to 90 degrees, and then they tell you B and C are complementary. Can somebody tell me why B and C are complementary?
The right angle triangle.
But why does it make B and C complementary?
Triangle adds up to 180 degrees.
Right.
Yeah.
Can you?
So A is 90 degrees,
Mm-hmm.
right? B and C must add up to
90 degrees, right?
Yeah, 90
Because to
degrees.
fill up the 180, right?
Yeah.
That makes B and C complementary.
Hmm.
Okay. So we can say that angle C is equal to 90 minus B, right? And we can say that angle B is equal to 90 minus C. Agreed?
Yeah.
Yes, okay.
Yeah.
You'll all understand that, right?
Yeah.
You understand why I never say 180 minus, I said
90.
90
Yeah,
minus.
but you need to
Because we give it the other way.
Because
What's the copy over the B?
it's to represent
Angle.
the angle.
Angle. Okay.
Is it because we give it 98A?
So, angle, so two angles are complementary if they add up to give you 90 degrees. So, complementary angles are two angles that equal to 90 degrees. Right? Now, why B and C are complementary is because angles of a triangle must add up to 180. Right? We know this 90. The remaining two must equal to what? If you add them together, they need to equal to 90. And from what we said here, if two angles equal to 90, they are complementary angles. So that's why this became complementary. So now I know that B plus C must equal to 90. So if I rearrange it, so I know that B plus C must equal to 90 degrees. This makes them complementary, right? So if I rearrange this, I said C, I took B across. So it became 90 minus. And then for B, that became 90 minus. Okay, that's where we are then. So if I had to ask you for sine of C, right? For sine of angle C, it's the same thing as me saying sine of 90 degrees minus angle B. Because I just replace angle C with that part. Okay?
Okay, right.
So sine of C is what? AB all over
No.
BC.
Why not? C.
sine of angle C.
Oh, yeah, yeah.
That's angle C.
AB
It'll be
over
AB over
BC.
BC, right? Okay. AB over BC in terms of the other angle is what?
Right? Right?
AB
Yeah.
over BC in terms of this angle. It's cos of that angle. Right? So this would be cos of
B.
B. Therefore, sine of 90 degrees minus angle B is equal to
Oh, sorry.
cos of angle B. Okay. Cos of angle.
This is an easier one, huh?
That's a much easier one. You just need the right angle triangle. That's the derivation of sine of 90 minus, if you say any angle, sine of 90 minus angle is equal to cos of that angle. Yes, Tom?
So for 90 minus, there should be no negative.
There is no negative for 90 minus.
Yeah.
For 90 plus, there's only 4 negatives, and it's for cos 90 plus, tan 90 plus, cot 90 plus, sec 90 plus. But if you remember cos and tan, you'll know that it's
The opposite.
the opposite will also be negative, right? So guys, this is how you would do the derivation for 90 plus, or the proof for 90 plus, and this is the proof for 90 minus. you want me to do one more leg?
You said cos n? Tan. is
Cos
negative.
tan
So sine
sec
will be positive. So
cos.
sine is positive.
cosec will also be positive.
So the cos rule applies.
Okay, I'm gonna do one more like how I did this one. Okay, I want it more for you want to do it, so you're gonna tell me how to do it, right? If I had to tell you cos of angle B, right? Show me the derivation or what would you do for the derivation? Or I want you to prove to me that cos of angle B is equal to, that one will make it sine of angle C. I'm asking you to prove that.
Okay, so we draw the triangle, we write all that information, C of angle there, right? Then we start from where you left off.
No, man, it's this.
So that, yeah, so
Sine
that's the
of
moment,
C.
right?
Is it a-
Cos
No, okay, you're going to write all that, right? I just want you to do it like how I did this.
Yeah.
Right?
So it's gonna be
So it'll be
So
cos
cos
of B
of angle B would be equal to cos
cos 90 minus C. Yes.
right? All I did was I swapped angles B, I replaced angle B
with
for 90 minus C.
Yeah.
Okay?
Then cos B.
What in terms of sides, cos of B is what?
As BA
B
over
over
BC.
BC.
Right? So you can say it's BA all over BC. In terms of the other angle, which is
what
C,
is that?
right? What is BA over BC?
Sine.
Sine.
Sine of C.
So remember everything here is equal to. All these steps are equal to each other, right? So this here is sine of angle C. So now because this is equal to that, if you take out that portion, that's equal to that.
Yes.
So cos of 90 minus angle C is equal to sine C. So in terms of co-ratios, cos of 90 minus the angle would equal to sine of the angle.
Okay.
Tops.
Okay, that's the derivations. So you can take down these two things. I'll give you all the co-ratios for that all you need to know, and then we'll do an example.
So that means you're done with cheat now.
Yeah, that takes you to the end actually.
Yeah.
Yeah.
Thank you.
What's the examples are problem?
These
proofs,
examples aren't so bad.
The proofs, identities. That's you don't see it, you don't see it. See, you don't see it. You just move on.
So it's the top proof that cos B is equal to sin C. You just say cos B is equal to cos 90 minus C.
So you would have. So this was the question, right?
Yeah.
So if you are answering it like you're in the paper, you would have shown here, this portion here, right? You would have drew this triangle.
Okay.
You would have showed that 90 degrees, and you would have said that angle B plus angle C must equal to 90. So then you would have showed, okay, from there you would have showed this part here. Then you come here. Then you say cos B, you swapped out B for 90 minus C. You show that cos B is equal to AB all over, or BA all over BC. But in terms of the other angle, BA over BC is sine of C. So this was equal to this, and that's how you prove that. Fancy's nice, guys. Fancy's very
Yeah,
nice.
everything's nice when you like it, when you know it.
It's just a lot of practice you have to. Because that's even before I come and teach, I have to go and practice one all night. But not happens next week. Sunday night, Monday night, Tuesday, Wednesday, Thursday night. I'll be prepping maths and science.
Yeah, such a nice week since I'm doing
Lucky Saturday I'm writing one, so I don't have to prep something for it.
So this Saturday we're writing maths, I mean.
Heavy subject.
That is,
You went through all the videos, Trust? Let me get a chance.
Also, it's find all these videos.
No, but there's a lot of other videos he also said.
Yeah, so he downloads straight into them.
No, not those. Yeah, those are the inputs. There's a lot of memorizing theory.
I didn't need time for it.
Yeah, time. I wanted to sleep. I love the
Sleep
night.
is overrated.
I love the nights.
Only for projects.
Yeah.
That's true.
Next month.
Next 3 weeks, just push. Honestly, guys, next 3 weeks, give it your all. You don't want to go into the paper thinking you could have
No,
done
we-
better or something.
Yeah, we always gonna think that. That's better, I think, actually. Go into the
As long as you get more than 50%, guys,
Yeah.
that's it.
I actually hope I get 80%. Yeah, take it like guys. Everybody got it?
Yeah.
Yeah. So, I take everything, right? So remember that page I told you to write down earlier with all the rules? You're gonna add what I'm gonna write now to that rules, right? this place. Come on.
It's hungry, yeah. Time for a break. Sorry guys.
Okay, these are your co-ratios, right? I'll give you the 6 that you need to know for 90 minus and the 60 you need to know for 90 plus. The only way I can say easier way to remember it, for 90 minus it's easy, okay? If they tell you sine of 90 minus, it's cos. If they tell you cos 90 minus, it's sine. Tan with its corresponding function that you would get is cot. In terms of these inverse ones, okay? Cot, it's the same like how this one is. So if you remember this one here, you know it's the reverse. For sec, remember I told you third derivative is what? Cos. Cos of 90 minus a is what? Sine. So third derivative here is?
Cosec.
Okay. So if you remember this first three, you will remember how these ones need to be. For these ones, these two are the same. And then it's negative, negative, negative. I'll figure out to help
You
you
have to
remember
just
that.
remember the cast.
Yeah, that will help you too. Okay, I'm gonna do one example, then we'll take a small break and then we'll do science set.
Okay.
Before
Yeah, got it.
I feel like this day helped to tell me where you are at and tell me where I need to be.
Yeah. Nothing for us as well. It tells us what we need overall for trig. So we got everything now. It's just doing examples everywhere. Yeah. What's sorry?
You can pause it.
Yeah, I can stop it.